Where we left off last time, we had the basic outlines of a working game. We have a game loop that keeps looping, although right now it's still looping forever. And we just rewritten the get next page for choice method so that it can respond appropriately when the user selects a number for their choice rather than typing the text of their choice. So how do we know when the game should stop looping? There's a lot of things that you can do. If you wanted to add, or if you wanted to extend this framework so that the player is not just someone who makes choices in the story, but actually has stats that can change. So the player might have health, or the player might be able to collect coins or objects. In that case, you could add more variables up here that describe your player, and then you could keep looping as long as your player's health is greater than 0, for example. A different approach, if you didn't want to get that complicated, would be to keep looping until they find a particular page in the story. There could be a last page, for example. Let's implement a version where some pages aren't the end. Some pages represent a bad ending, like death, and some pages represent a good ending, like you have won the story. So in that case, the type of ending that a page has is a property of the page. So we should add another variable here at the top of page. Let's make it an integer called endType. And then we can change the page constructor to set the ending type. So int end. And we'll use a code. Sometimes it's nice to type the code out so that it's not confusing. So we'll say private int not ending is going to be 0. Private int win is going to be 1. Private int lose is going to be 2. So what that means is the number inside this variable is either going to be a win or a loss or not an ending yet, depending on what you set for this page. So let's set this dot end type to be equal to end. And this is just the same as the regular way a constructor initializes those variables. So whatever this input is, end, is now going to get assigned to that variable. So that means back in main, we need to change it a little bit inside initialize game. Each of these we've got to describe not only the text for the page, but whether or not it's an ending. So we'll probably change this in a second, but 0 represented not an ending, 1 represented a win, and 2 represents a loss. So now it's a very short game. The right thing to do is to go left to the waterfall, and in that case you win. Otherwise, if you go right to the ogre, you lose. So now that we've got this in place, down here, when you go to the next page, you could do this. You could say if current page dot get ending equals 1, then that means there's a win. So you could print out congratulations, your journey is done. Otherwise, if current page dot get ending equals 2, that means you've lost. So you could print out a losing message. I don't have an if statement for testing if the ending is 0, because if it's 0, that means we're not at an ending yet, and I want it to keep going up to the top of the loop. So now in the while loop, I can say if current page dot get ending is not equal to 0, because as long as it's not the end, we want to keep going. No, that doesn't make sense. We want to keep going as long as it equals 0. We want to keep going as long as it's not the end. Okay, 2 things to fix. We didn't actually make a getEnding method. This is why getter methods exist, because the page knows whether or not it's an ending page. But because the variable is private, we have no way of accessing that from the other part of the code. So let's write our getter method. Get ending, and we're going to return this dot, what was it? Ends type? Did I really call it get ending back here? Yeah. Okay. So now we've written that method. And then the last thing is these zeros and ones are kind of mysterious. These are called magic numbers, and that's a bad thing, not a good thing. And the reason they're called magic numbers is because another programmer would come along and look at this code and think, what's so special about 0 here? Why is 0 the magic number that makes this code work? And you and I know that we are using our own code where 0 means that the game isn't over yet. But that's totally hidden from somebody else looking at this code. So let's fix that by going back to page. Instead of making this private, let's make it public. And what that means is that we can use these names instead of the numbers themselves. So now if I go back to main, instead of not ending, I can say, let's do one more thing. Let's make them static. Static means that the page class itself has these methods, and we don't have to refer to a specific page. So now we can say page dot not end. Is that what we called it? Not ending. And now this reads more easily. We're saying while the current page's ending is equal to not an ending, keep going. Same thing down here. We'd say page.win. And here we'd say page.lose. And I think that that makes the code more easy to interpret when you're reading it. One more thing that we'd want to do is we don't want any other parts of the code changing the numbers inside these variables, because this code is never supposed to change. 0 always means not an ending. 1 always means a win. So if you use the keyword final, that means that the values here are final and they will never be changed. So it makes these variables into constants. Let's do one last thing. Right now the game as it is a little fragile, and I'll show you how. So right now we display our messages and you type 0 to go left and right to go 1. What happens if I type a number that's not 0 or 1? What happens if I type 7 or the word lobster? In that case, it just crashes. And there's a lot of text here, but this part is telling you the type of error that's happening, index out of bounds. And what that means is that we're trying to access a location that doesn't exist. And not only that, but it's telling us that 7 is the location we're trying to access, but the list is only length 2. So what's happening here, I hope you can guess, inside page, down in get next page for choice, I typed 7, which is user choice. I'm immediately converting that into a number, and then I'm trying to get that number out of my list, but that number doesn't exist in my list. So let's add some safety checks in here so that it won't just crash if the user input is unexpected. We'll have it do something that is more normal. So the first thing we should do is, what happens if the user types the word lobster? In that case, this line will crash because you can't convert the word lobster into an integer. So a good thing to do here is a new part of Java you don't know yet. It's called the try-catch block. So I'm going to say try, and then I'm going to have an opening and a closing curly brace. And what that means is Java's going to try and do all the lines of code that are between the braces. But if an error happens, we're going to catch that error. And in parentheses here, we have a variable that will hold information about the error that happened. So the word exception is the type of variable we're going to have, and error is going to be the name of our variable. And then you have a new set of curly braces. I think what we're going to do, so if the user had typed lobster, so if the user had typed lobster, that word lobster, Java would try and convert that into an integer. It would cause an error inside try. And so immediately we'd catch that error, and instead of crashing, it will run whatever code is here inside the catch block between the curly braces after catch. So if there's an error, we don't want to crash. What we want to do is we want to print something like, please type the number of your choice, to give them clearer guidance about what we want them to type. We still need to return something though. So let's return this, which is the current story page. So we'll give the user another chance. It will just redisplay the text from this page, the same options, and the user can try again. Okay, so that handles the situation where maybe they didn't type a number. What if they type a number that's not part of the list? What if they type -5 or if they type 100? So the next safety check is we have to test to make sure that the number is a valid location number for our next page's list. So we're going to say if, so let's, what I'm about to type isn't going to work unless we create the choice variable up here. So let's create choice to be -1 by default, and then delete this part because that's going to create a second variable also named choice. So now what we're doing is choice starts by default at -1, which is not a valid choice. If this works, we get assigned a choice that really corresponds to what the user said. And so now we're going to test to make sure choice is a valid location. So choice has to be between 0 and the last location in the list. So we're going to say if 0 is less than or equal to, or maybe it's easier to think about it this way. If choice is greater than or equal to 0, we know it's not too small. And choice also has to be smaller than or equal to the size of the list, which is next pages.size. As long as both those things are true, we know that the choice is valid and we can go ahead and get the page that corresponds to that choice. Otherwise, we know the choice was bad, and so we can print a message that will tell the user that. Try again. And then just like last time, we'll return the current object so that they'll have another chance to type that same thing again. All right, so let's run it one last time. Here we are. So I'm going to type the word lobster, and it says, please type the number of your choice. I'm going to type the number 9, and it says that your number isn't a valid choice. Try again. So I'm going to type 1, and it still thinks my number is not, wait, what? Oh, it says, sorry, try again next time because I went to the ogre page. So this is maybe one more thing to fix because I never even got to see the text from the ogre page. So that's why we test things. Let's go back to main. And then here, if the current page .getEnding is a winning page, I still want to display the current page's text, but not the choices because it represents an ending, and so there are no choices. So if I won, I'll display the winning text from that page, and then congratulations, your journey is done. And then when I go back to the top of the while loop, I'll exit. And then probably the same thing for the losing page, if it's a losing page. Let's run it one last time to make sure that it looks good and we're happy. So here we go. I'm going to type 1 again. And now it says there's an ogre on a pile of rocks here. Sorry, try again next time. Great. So that's it. Now all you need to do is flesh out the rest of your story. So we only have a very simple one where I've just got 3 pages. You want to make lots of different pages and link them together in interesting ways. You can also feel free, like I said, to add more variables up here having to do with your player's stats. So you could say public static int health or public static int wealth or public static int stealth or, you know, that kind of thing. And so you can give these variables initial values at the very beginning, and then depending on what happens in the page, you could actually change those values. This is not the best design. If you wanted to make this more complex, you'd actually have a player object, and you could give your player objects to each page and have the page decide what it does to your player object. But that can be for a different time. Good luck, everybody.